Hi everyone. We're going to jump in and do some review of rational functions, and then the next section we'll jump into all the graphing rational functions that we want to do. So this is a great example, maybe a little messier than what you would have seen in Pre-Calc 1, but not too messy. A rational function has a polynomial numerator and a polynomial denominator. And for the purposes of what we're doing here, you're mostly going to see linear over linear or maybe some quadratic in the mix. But definitely variables in the bottom of the fraction, and you'll see a lot with variables both top and bottom. All right, so again, just some kind of brush up, get used to function notation stuff again, and all the algebra that goes with polynomial and rationals. So first thing we're supposed to do is evaluate g of 0. So we're plugging 0 into our function. Remember, you need to take this rule really literally. So it's saying your function will take whatever you give it and multiply it by 3 and put that in the top of a fraction, and add 4 and put that in the bottom. So 3 times 0 is 0, and 0 plus 4 is 4. And this is a really good reminder. I know, not a terribly hard problem, but just to get us started, 0 divided by 4 is 0. So it's absolutely okay to have a 0 in the numerator. It is not okay to have 0 in the denominator. All right, so let's look at g of -4. So again, g takes whatever you give it and gives you 3 times that in the numerator, so -12 in the numerator, and it gives you your input plus 4 in the denominator, which is 0, which means this is undefined, or you can use the does not exist if you'd like. We start to use that a lot in calculus for a limit, so if you want to start using it now, I think it works fine here. And that leads me to another reminder. What we're finding there is that -4 is not in the domain of function g. So if you're looking for the domain of a function, remember that our big problems are division by 0, which does happen for some of our trig functions. We saw that, so we got a little bit of a reminder. Even roots of negative numbers, so like no square roots of negatives. And then we also don't want to take logs of 0 or negative. This is a fraction, so we're only worried about the division by 0. And in fact, -4 is the only thing that would give us a problem. I used a funny variable here, so let's stick with it. Y is actually our input variable. So we would say that the domain is y not equal to -4. And that very much means everything is okay except for -4, and that is true for this function. Okay, getting into a little bit of the more algebraic stuff, and if this is really fresh for you and you don't need the reminder, just pause and try these out and then check yourself. You can rewatch if you missed anything. G of 2 over y, I like this because we're going to get into some complex fractions, which happen a lot in calculus. So we're going to take 2 over y and multiply it by 3 in our numerator and add 4 in our denominator. Remember, this is like a 3 over 1. A lot of people make mistakes even just with that 3. They'll multiply top and bottom. But really what we have is 6 over y divided by 2 over y plus 4. All right, so we've cleaned up the top a little, but we definitely still have a mess. We have a complex fraction. We have fractions and fractions. So we're going to clean that up, and we just practiced that. So I'm going to emphasize my more efficient way here, kind of the shortcut way, which is to clear the fractions. But I will say again, that it is fine with me if you're a little more comfortable performing things carefully with order of operations, which would say you do the addition in the bottom first to get a single fraction, and then you would flip and multiply to perform the division that that big fraction bar is indicating. If we're going to do the clear fractions way, we want to look at our internal, these smaller fractions, and say, okay, what is the least common denominator? And that's actually pretty easy in this one. It's just y. They both already have the same denominator. So we need to multiply top and bottom of the big fraction by y. And if you need the reminder, that's like a y over 1. Just like with the 3, we're not going to multiply top and bottom. We're going to multiply numerators only. So again, I'm going to write what I have, but if you start to get comfortable where you can see what's going to cancel out, you can skip this step right here. Really important, biggest thing I see, I think, with this is not remembering to multiply the 4. So we get a 2y over y and a 4y over 1, so we don't need to write the over 1. And notice, here's what we were hoping for. Y's canceling out. So on the top, I just have a 6 over 2 plus 4y. I can reduce that a little bit, so I think I may as well. I'm going to factor a 2 out of the bottom. Here, I'll just write it below. So it's a 1 plus 2y. And then I can cancel that 2 out, and it leaves just a 3 in the top. So I'm seeing a 3 over 1 plus 2y. All right, so lots of complex fractions will show up in this section, and just work through carefully, embrace the algebra practice. It'll be really helpful. Next, I have 2 over g of y, and this is just reminding you again what all the function notation means. So this says take the output of your function, g of y is equal to 3y over y plus 4, and put a 2 over that. So we're going to say, okay, I have 2 over the entire function, which is 3y over y plus 4. You could absolutely use the trick we just used, multiply top and bottom by y plus 4, but I would point out we don't have the addition in the middle that we did in the top. That's just a single fraction. It's 2 divided by a fraction, and the way you divide fractions is you multiply by the reciprocal. So we don't have to use that trick. It would 100% work, but we don't have to use it. We can also just flip and multiply. And then I'm just going to mush that 2 into the fraction. You can distribute it through or not. I don't have any preference on that. I just want to see you able to work with all these tricky fractions. All right, probably most important for heading on to calculus is the difference quotient. Difference quotients for rational functions are absolutely going to come up. So we need to do multiple steps here. We're going to need to figure out what g of y plus z is. We will need to figure out what g of y is. That's not hard to figure out. It's given right at the top, but we need to plug it in, and then we need to subtract and divide by z. So number one, if I plug a y plus z into my function, I get 3 times that y plus z. Remember, all the way up here at the top, that's our function rule. I'm even going to highlight it so we keep looking. People, as they get into these problems, start to lose track of, oh yeah, the rule was 3 times input divided by input plus 4. So 3 times y plus z divided by y plus z plus 4. Notice I put parentheses around my input both places. I don't really need them in the bottom. The only thing attached is addition. But if in doubt, put parentheses around your input. You're never going to be wrong to have them there. You might just be able to drop them, but you're not going to be wrong to put them there. You could be wrong, like in the numerator, if you didn't put them there and you just did 3 times y plus 1z, we're going to need 3 times y plus 3 times z. Okay, so that's my number 1. And then we're supposed to do a minus, so that's this minus right here. The original function g of y, which is a 3y over y plus 4. We're going to divide that by z. Okay, so really ugly. I'm going to go ahead and scroll up. This is where we start to really want to have this good trick where we can clear fractions in fractions. So I want to look at the 2 internal fractions, and I want to multiply by their common denominator. And while I know it's tempting, they both have a y, they both have a 4. Y and 4 are not factors. Y plus 4 is a factor of the second one. Y plus z plus 4 is a factor of the first one. Basically, you can't factor them anymore, so it's the entire denominator is a chunk. So we'll multiply by a y plus 4 and a y plus z plus 4. And we can't do any better. If you need the reminder, put that over 1, and then we'll do it to the bottom as well. Y plus 4, y plus z plus 4. Okay, and I'm not going to put that one over 1 because there's no fraction in the bottom. So what we get, we need to distribute it through, right? So we need to multiply the first fraction and the second fraction. And I'm not going to write this whole step out because it starts to get really big. If you get a little lost, just let me know and I will write it out for you, work it through with you. But I want you to start to try and see what's going to happen. So when we multiply fraction number 1, what will happen is this denominator will cancel out with this y plus z plus 4. So we will be left with the 3 and the y plus z that was in the top of that fraction, and then also the y plus 4 from the common denominator. Okay, and then we have the minus, this minus right here. And then we need to basically reset. So forget that you canceled anything out of that. This is an entirely separate step. We're distributing that through. When we distribute through to the second fraction, the y plus 4 will cancel with the y plus 4. So we will be left with the 3y from the top of the fraction and the y plus z plus 4 from the common denominator. And then in the bottom, we have a z times y plus 4 times y plus z plus 4. Okay, so our real goal here, even though it just says simplify, when we hit calculus, the real goal is to cancel out that lonely z, that single z that's in the denominator, so it's this one right here now, which means that when we clear the fractions and fractions, we're really hoping to be able to factor out a z. So let's go ahead and for now, since it's in this weird partially factored form, it's separated by that subtraction. Let's go ahead and clean up, get rid of all the parentheses, and then see if we can regroup and actually fully factor when it's not in this partial factored form. Okay, so I'm going to do one step right above. In this part right here, we need to FOIL that out, so we're going to multiply the first 2 and get y squared. The outside 2 is 4 times y. The inside 2 is z times y. I'm going to do yz. I like to alphabetize mine just so that I have an order, not that it matters. And then plus 4z is the last. And then the reason I wanted to sneak that in is because I also have to distribute the 3 through. So I'm going to go ahead and do that here because I don't have a ton of room. So I see a 3y squared plus a 3 times 4, so 12y. Plus a 3yz plus a 4z. And then I need to distribute a negative 3y through the second set of parentheses. Very careful with the negative. Missing a negative is the most common mistake here. So I have a negative 3y squared minus 3yz minus 12y. Almost lost it for a second there. And that's all over z, y plus 4, y plus z plus 4. Often people wonder here why I don't multiply the bottom out, and that's because the bottom is truly in a fully factored form, and that's perfect for fractions because I could at any point cancel the z out of the bottom or the y plus 4 or the y plus z plus 4. Again, remember with the top, we had this subtraction in the middle, so it wasn't fully factored. The big operation was subtraction, not multiplication. But in the bottom, the big operation, the most important operation there is the multiplication. All right, so looking at what I ended up with, this is the step where nice things should happen. I'm seeing a 3y squared and a minus 3y squared. I always think this step's really gratifying because you just get to cross things out. A 3yz and a minus 3yz, a 12y and a minus 12y. It doesn't always work out quite that beautifully, but all I'm left with there is a 4z divided by z times all my other stuff. So normally I'd write another step here, but I think since it worked out so nicely, I'm just going to go for it and say, well, I can cancel a z out. So that's z divided by z, whereas what I was doing before was saying 3y squared minus 3y squared is 0. What I'm saying now is z divided by z is 1. So all that I'm left with is a 4 on the top and a y plus 4 times y plus z plus 4 on the bottom. Okay, this one's getting long, I know, but hopefully this isn't too tricky to watch through. This is supposed to be mostly review and maybe a little bit messier than what you saw in Pre-Calc 1. Last part here says solve g of y equals y. And for whatever reason, people will hit this one and just really get a mental block on what it's even saying. Remember that g of y, this isn't defining a new g of y. It isn't saying g of y is just equal to y. That's the whole function. It's saying our original function g of y needs to be set equal to y. So remember, our original function g of y is up here at the top, and we're going to set that equal to plain old y. So 3y over y plus 4 equals y. And notice the algebra is what we just reviewed, so we'll just need to solve a rational equation. Here, I would say let's go straight for clearing that denominator since there's just the one fraction. We'll multiply by y plus 4, which means it cancels out on the left-hand side. I just have a 3y. On the right-hand side, let's go ahead and distribute through. We get y squared plus 4y. Avoid the temptation to divide everything by a y. You'll lose solutions. We saw that with the trig equations. That was kind of a tricky thing for people. But if you divide a variable out, you can lose solutions. The alternative is to move everything to one side. So I'll subtract 3y from both sides, which 4y minus 3y leaves just a 1y. And then instead of dividing out that y, you factor it out. And now it's still there, and it tells you that y equals 0 would make this a true statement. And we also know that y plus 1 equals 0, or y equals -1 would make this a true statement. Remember, this is a rational equation, so you really need to check. So looking back at our original equation, y can't equal -4, but 0 and -1 are both totally fine, so we will keep both of them. Okay, so there was a chunk of function notation, and we'll look at some of the other function stuff as well, but hopefully that gets you started.